All right, we are here with period 4 going over our review from chapter 3 talking about functions for our test tomorrow. We're going to start with number 15. It says to find f of g of x and g of f of x. So let's find f of g of x first. How did I teach you guys to do this? With the box, right? So the way I view it is if you read it, it's f of g of x. So I'm going to write down the f of x function. All right, that comes first. So I'm going to write down 3x plus 2, but instead of an x, I'm going to put a big box to replace the x with my other function, g of x. All right, so that's going to go in the box in parentheses. And because we have a 3 out front, what does that 3 need to do to each of these terms in the parentheses? Distribute, so you get 15 minus 18x plus 2. So if you clean that up, you'll get negative 18x plus 17. And that's the answer. Everybody good with f of g of x? So it's 18x with a negative in front of it, so that's going to start it off to listen, and then 15 plus 2 gives you 17. Okay, let's do the other one, which is g of f of x. So I'm going to write down the g of x function, 5 minus 6x, but put a big box instead of x, and replace that with 3x plus 2. If you distribute again, you get negative 18x minus 12. So what is g of f of x going to be? I heard minus 7. Why minus 7? Very good. So just be careful there. It's a little different than the previous one. Questions on composition? Question? Check it out. You got it. Everybody good? Okay, that was 15. Who's got another one for us? 21. Excellent. Let's do 21. All right. I guess the first thing that I do when I read this question, because it says to write the equation for this function, is you got to know what this function is. Somebody said it. It's the absolute value function. From your days of probably sophomore year, some of you junior year, where you have the v. Anytime you see a v, that's an absolute value function. All right? So if I wanted to plot the parent function, it would start at 0, 0 and create this v. Everybody go with that? So that would be f of x equals the absolute value of x. But you'll notice the blue one up here, the blue one looks like this, but it's not in the same position. It's been shifted. How has it been shifted? 3 to the right. So the question is, how do you write the answer? If you know it's 3 to the right, which it is, right? 3 right. What's that going to look like? Why in the absolute value, Jalen? Very good. So Jalen's right. Anything outside would be up or down. Anything inside is going to be left or right. And just be careful when you do inside. You want to think opposite. 3 to the right is actually a positive 3, but you'll notice when we wrote it, it's subtraction. Questions on 21? That was a little tricky. Or it can be. All right, who's got another one for us? That's it, we're done. Video over? Yeah. Oh, 22. If it was college, I'd let you go, but it's not. Only one chuckle. I'll take it. All right. 22. Find the inverse of this function. This is, I think we did this at the very last lesson with 3.7. where you had to follow those 4 steps. Who remembers step 1? F of x becomes y. So step 1 is y equals 9 plus 10x. That's step 1. What's step 2? Switch. Very good. So x equals 9 plus 10y. Ooh, step 3. Solve for y. So the first thing I want to do is what am I going to move over to the other side? The 9. So if it's positive 9 here, what is it when I move it over? So if x minus 9 equals 10y, what's going to be the last step? Divide by 10. So we have a couple ways to write this. X minus 9 over 10 equals y. That's acceptable? All right, the cool kids would write it as x over 10 minus 9/10. All right, hashtag extra. What's step 4? If it's a function, you've got to do what Sabrina was saying, and she was saying something like f to the negative 1 power of x. That's called inverse notation. So is this a function? Is this right here a function? X to what power is happening? It's x to what power? X to what power? There's no power, right? So if there's no power, what is it? It's to the first power. And what kind of function is x to the first power? Linear. So it's a linear function. So do we need to do step 4? Yes. So the answer should be f to the negative first power of x equals x minus 9 over 10. You will not get full credit if you don't do that. Now, there is a chance tomorrow that it's not going to be a function, and you would not do step 4. Do you remember the only one I've taught you so far? What's the only one that's not going to be a function? The plus or minus what? The square root. Remember that one? If you end up having plus or minus the square root, when you sketch that, it would look like this with both parts of that parabola, and that fails. I guess it's not right there. That fails the vertical line test. Yeah, I don't know why you hate me so much. That fails the vertical line test. Emmanuel. That's the only one we've talked about. I mean, I can't tell you all the stuff, right? I feel like I've made it fairly clear that the only one we've talked about is plus or minus the square root. I can't say it's the only one because there are other indices here that could happen. What's the little number here that's invisible? It's a 2. Very good. There are also any numbers you want to put there, like 4, 6, 8, 10. Any number you can put there, 3, 5. But the even ones is when you have the issue with the plus or minus. The even indices. Index plural. Indices. 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 Not industry. Index. Indexes. Everybody good with, I know we got a little crazy there, with 22. Okay. Who's got another one? Yes, 23. All right. Now, when you read this, what ultimately am I trying to get you to do? To see if they're inverses of each other or not. That's what I'm trying to get you to do without actually telling you that's what you're doing. Right? If you read part B, it says, what does it tell you about the relationship between them? I'm trying to get you to say either they're inverses of each other or they're not inverses of each other. All right, that's what I'm having you do. Now, if you were paying attention to, I believe, 15, this is composition again. So we have f of x, which is x cubed minus 5. So I'm going to do box cubed minus 5. What's going in the box? Very good, which is the cube root of x plus 5. What happens when you cube a cube root? Right? They're inverse operations, so bye-bye. So you have x plus 5 minus 5, which is just x. Now what happens when you get just x? What does that allow you to do? The next one. What if I had not gotten x there? Then you can stop and write what, Sabrina? They're not inverses. Very good, right? You can just stop right there and write they're not inverses of each other. That didn't happen, so I must do g of f of x. So we have cube root of box plus 5. All right, so hopefully your brain can see I just wrote this function, but I left a space for x. All right, which is going to be x cubed minus 5, the other function. You'll notice there's nothing happening in front of that parentheses, so I can imagine the parentheses go away. What's minus 5 plus 5? 0. So you have the cube root of x cubed, which is x. So they're both x, so what do you write for part B? Great. I think on the key I wrote f of x and g of x are inverses of each other. But you could write they are inverses of each other. That's fine too. I would say that this is a question where if you get this question right, it's a very good indicator that you're going to do very well on the overall test. All right, this is one of those that kind of separates students into two groups. Did well, not well. Because it requires a lot of understanding, composition, what does it mean, what are you writing for the sentence, that kind of stuff. 6 vocab. The sentence is f of x and g of x are inverses of each other. I think I saw your hand first, Aiden. Okay. Yes, okay. Matching. 6 matching for the vocab out of all those. So you have to try to guess which ones did I pick. Would I be lying if I said I don't remember which ones I picked? I wouldn't be. Made the test last week, so I couldn't tell you. Oh, good. That's back. Is it, though? Because I sure heard a lot of pounding. Who's got another one? 18. You know what? How about I one-up you and let's just do 17, 18, 19, and 20. How about that? Let's do that because it's all kind of the same. We're doing 17 through 20. Transformations. All right, so let's start with 17. I think the first thing I would recommend doing is deciding what the parent function looks like. So what is the function in 17, Jalen? Yes, what function is happening in number 17? It's a quadratic function. You're going to sketch a parabola. Here's x squared. Right, everybody see that's x squared. We good there? So if it says x minus 3 and the minus 3 is in the parentheses, how is it being shifted? To the right 3. So I'm going to start it at 3, 0. That is it. Pretty good? Hey, Peter, you made it. We were worried about you. Everything okay? Yeah? Did you bring anything with you? All right, then. What I'd recommend doing tonight is watching the video. All right. Well, tomorrow morning when I see no views. Okay, let's look at number 18. Go to bed. What kind of function is this? Square root function. Do we know what that looks like? It's the half of the parabola, right? Looks like this. Now you'll notice, does it have the plus or minus? It doesn't have plus or minus, so it's just that piece, which makes it a function. Makes it a function. But it's not just the square root of x. It says plus 5 outside the radical. So that's 5, 5 up. So when I sketch the real one, it's going to be up here. Question? Pretty good. Bless you. Number 19. Ooh, this is a good one. What function is happening in number 19? It's a cubic function. Do you know what x cubed looks like? Yes? Yes, and actually because it's x cubed, it only crosses at 0, 0. All right, but it has that kind of like flatter cross instead of like the parabola where it hits and comes back. So you're going to learn on Friday, that's called a triple root. All right, when it kind of does that like flattening out as it goes up and crosses. So it's not just one root, it's triple. It's happening in your mind. Think of it as happening 3 times, even though it's at the same spot. So that's not the answer, though, because of that negative. What's this negative going to do to this function? Right now, it's doing this. Right now, it's like this. So how's it going to change? Like that. All right, a reflection. Something like that. So I know on my key I had it hit 3 times. I was actually that's just wrong. Sorry. It's going to be, you're going to see when we do stuff Friday and further on that when we do cubic functions that have like x cubed plus 2x squared plus 6x plus 8, that will hit. That'll be like that. Okay? But since it's just the parent function, it actually should hit 1 time and like cross like that, triple root. All right, my apologies. Let's do number 20. Ooh, this is a good one. I'm not going to do the parent function because we already know it from number 17. It's quadratic again. But you've got multiple things happening here. What's going to happen with this plus 2 and the minus 1? Left 2 and down 1. So left 2, and I have to do it. You know I have to do it, right? Down 1. No? You don't know what I'm about to do? Wow. It's amazing. This time, 3 years ago, is when I met them. This time, 3 years ago, is when I met Liam and Niall. No, so the tournament that I went and saw them at, like golf tournament when they were there, you can't bring your cell phone on the property, like policy. I'm not lying to you.
I've been to golf tournaments. That is not a rule.
It's not a rule except for this one tournament. Google it. The Masters tournament. It's happening this week. Masters tournament. Masters. Look it up. Masters cell phone policy. Look for it during the tournament days, Thursday through Sunday. No phones on the property.
Ha! They don't do it on Sundays. It's only on Fridays.
No, it's Thursday, Fridays. Okay. All right. So I'm going to go left 2, 1 down, and put a dot. But I'm not going to draw my parabola opening up because of this negative. What does that negative mean is going to happen? Opening down. What? Okay. Any questions on 20? Yes. Means it's going, instead it's going to be a vertical reflection, up to down, down to up, back. The negative inside, like if it had been like this, negative x plus 2 squared, like that, that means it's going to be the horizontal left to right reflection, right? So it'll be like, instead of going left 2 and opening like this, it's going to go, wow, super to the right. Okay. All right. Everybody good on 17 through 20? Who's got another? Yes, Edgar. Number 3. Excellent. Number 3. I love it. All right, number 3 is an absolute value function that they want you to evaluate with 2 input values, -3 and +2. So if I do f of -3, 2 times the absolute value of 3 times -3 minus 1. Okay? Edgar, let's see if you got it. What's 3 times -3? Minus 1. What's the absolute value of -10? 10 times 2. You did it. Perfect. Done. Okay. See if you can do the other one. I'll give you 30 seconds, Edgar.
Will be 6 minus 1. So then we'll be +5.
Great. Who's got another one? 9. Let's do it. Ooh, piecewise. Okay. With piecewise functions, what I would highly recommend doing is creating 2 t-charts to plot your points. So we have the x plus 1 piece and -2x minus 3. All right? So when I use this piece, I need to look at this inequality, which says values for x that are less than -2. So what are values that are less than -2? 3, 4. Yes, okay. So again, you can stop whenever you'd like there. But you're going to notice something. I wrote -2. Why did I write -2? -2 is not less than -2. I'm breaking the rule. What do I have to make sure to do when I break the rule? Open circle. All right, so something that is helpful there is to make sure you know to put an open circle when you break the rule. All right, so let's see. What's -6 plus 1? Yes, Phyllis. Like this little guy? I do that for me, like say, hey, make sure this is open. I don't need to see that. I'll be grading this. But if something's wrong here, then I'll look here to see if I can find your mistake. Just like on all the tests we've done, the more work you show, the more chance I can give you points. Okay, so what's -6 plus 1? Okay, and then -4. All right, so we need an open circle at -2, -1. And then we're going to have a line going this way. I usually, what my teachers would tell me is go to the edge of the, like that, edge of the grid. Okay, what about the other one? The other piece of this function says values for x that are greater than or equal to -2. So what are those values? -2, -1, 0, 1, 2. Okay, we got the idea? So if you plug these numbers in to this function, what's -2 times -2? 4 minus 3, +1. If you do the same thing here for -1, 2 minus 3. You'll notice we're going to start decreasing by 2 because the slope is -2. All of these points will be filled in, right? Right, see that? I don't have to worry about open here. So we have -2, +1 is closed. Okay, any questions on piecewise? Somebody in my other class asked, what's the domain and range of this? I didn't ask for it, but do you know what the domain and range of this would be? Just for fun? What's the domain? What values for x could we use? Negative infinity to positive infinity. Do you see how the arrows are going in both directions forever? So we got all the x values are good. Now, did we use all the x values? No. But in terms of the domain, it's any value for x is fine. What about the range? What's the lowest y value? Where are the arrows going? Negative, right? So we have negative infinity. But what's the highest y value? What's the highest y value? The highest point is here. What's that y value? 1. Is it included? Is the circle closed? So it'll be a bracket. I'm not going to tell you if that's on the test or not, but some student was like really worried about it, so we talked about it. What if it was open? What if this point, what if it had switched, right? What if this had the or equal to and this was not or equal to? Then this one would be closed and that would be open. So this would become a parenthesis. That? No, sorry. This is negative infinity. This is a 1 closed. Okay? That's number 9. Who's got another? 12. Excellent. Okay, this is the increasing, decreasing, constant one. Awesome. I don't care which order you write it. And also, if you remember when we did this in class, I don't care about brackets, parentheses, just use all parentheses. Okay? So, when I look at this, if you read it from left to right, it's starting constant. Do you see how it starts? That little piece is constant, the bottom left. So that means my lowest x values for constant, it's going to start negative infinity. When does it stop being constant? Right here, which is negative 3. And then it becomes what? That's increasing, right? We're going from bottom left to top right. That's increasing from negative 3 to, what's that x value? It's always x values. Positive 1. And then we're back to what? Constant. So that would be the u. And then 1 to infinity. Notice, did we have any part of this function that's decreasing? We did not. So it might happen on the test tomorrow that you don't have one of them. Is that good? Okay. Any others? We still have 8 minutes. Going once. Yes, Peter. No? Okay. You had me there. Are you raising your paddle? Gotcha. Just watch the video tonight. Yeah, right now. You're on it. Hello. Pretty good? All right.
People of America.
Number 7? Yes, we're not done yet. We thought we were done, but Jalissa pulled us back in. Number 7. All right, now we're using this parabola to evaluate f of 2. So when you look at your x value is 2. So go to 2. Where is your function? When x is 2, where is the function? It's also at a y of 2. All right, what about when it's 0? When x is 0, where is the function? Negative 2. So that's how you do it. Look for the y values after you get to the x. All right? You're in here for 11 minutes. All right, who's got another? Or are we finished? 4, 5, and 6. Yes! I thought we were there, but no! We're still going. All right, 4, 5, 6. The way you want to do this when I give you the graphs is first do your vertical line test on all of them. So if you do your vertical line test, do any of those fail? No, the vertical line test, remember, you're looking to see if any of them have 2 points on the same vertical line. I think only this one. Right? I think the other ones are functions. So 5 is a relation. But 4 and 6 are functions. Now, what I always say is, if you tell me it's a function, right, Mr. Branch just said it's a function, then you should be able to tell me what function it is. So which function is this if it hits 1, 2, 3 times? This is a cubic function. And what about this one? Ooh, what about this one? Oh. Which one? Not quadratic, that's the parabola. What is it? Not square root, is that like the one that goes like that? What is it? It is 1 over x, but what is that called? What is 1 over x called? Not inverse, but I see why you're saying that. Starts with an R? It's not a rational. Rational. Okay, is everybody good on which ones are functions and which ones not? Now the question is, once you check the functions, right, you see that they're functions, then you want to ask yourself if they're one-to-one. The definition of one-to-one that's in your key terms probably says something to the effect of each input has a unique output. So there's no repeats in the y values. All right? So we test that graphically with the horizontal line test. So if you use a horizontal line test, you'll see this fails a lot. Right? You see how there's multiple x values that have the same y value. So this is not one-to-one. Am I saying it's not a function? No, it's still definitely a function. It's just not one-to-one. It's not a special function. Okay? Now 6 or 5 I don't check. Once you say it's a relation, you're done. There's no way it can be one-to-one if it's a relation, because one-to-one means it's already a function. So let's check 6. I don't think there's ever a place where there are 2 x values that have the same y values. So this is called one-to-one. So it's a one-to-one function, number 6. Questions? So the reason I don't even check 5 is because it has to be a function first before it can be one-to-one. All right? Like a rectangle has to be a quadrilateral first before you even get to the idea of seeing if it's a rectangle. All right? So when I'm showing my daughter shapes and she like points and it's a rectangle, I say it's a rectangle, but it's also a parallelogram and a quadrilateral. So she understands that it's more than just one thing. It's geometry. Questions? You guys don't believe me again, I guess. That's fine. No questions? Okay. Shall we sign off? All right. Thanks for listening. Hope you enjoy this. And Peter, hopefully you're still awake. I better post